Okay, so for the lesson 10 homework, first thing you're going to do is you're going to read this little excerpt that kind of gives you background information into what the chart and spreadsheet is that you're going to work with. So let's read this little excerpt. Part 1. What are orbits like in our solar system? An orbit is a regular repeating pattern that one object takes in space around another one. Orbits come in different shapes. So let's pause for a second. An orbit, there's in this picture, there's two orbits shown. One is this green orbit that this object, the Earth, takes around the sun. And then another is a comet's orbit, this white one here, that it takes as it travels around the sun. Okay, so we might notice that orbits don't look like exact circles. So we're starting back at the second line here. Orbits look more like thin ellipses are ovals, than they look like circles. Objects that orbit stars like the orbit stars, like the Earth, do not always stay the same distance away from Earth throughout their orbit. Sorry, this is supposed to say the sun. Sorry. Okay, sometimes objects are closer to the sun and sometimes they're further away. For example, planets vary in distance as they orbit or move around their central stars. So the closest point that a planet like Earth comes to its central star is known as the minimum distance between the sun. So like here, if you can see where my cursor is, here you would see it's a lot closer to the sun than it is here. So this might be one of the minimum distances to the sun. However, we know that the maximum distance from the sun would be its farthest point away from the sun. All right, so let's scroll down here where it says analyzing and interpreting data. Number 1, open up the LP10 homework planet data analysis graphs that is attached to this assignment. So if I go here, whoops, if I go, that would be this thing right here. Okay. Oops. All right, on tab 1 of the spreadsheet, plug in the data for the average distance from the sun, AU, that just stands for astronomical unit, and the period of revolution. That's just how long it takes the object to orbit around the sun once. So, for example, if we look at the Earth here, the average distance that it is from the sun is 1 Earth. It's 1 AU. And then the period of revolution, this is measured in Earth years for all planets. So this is 1 Earth year. But we see that Mercury has a much shorter revolution and only takes about 0.241 Earth years to travel around the sun. So right now, all you're doing is you're plugging in the rest of the data for these two columns, the red column and the orange column, in here. And as you put in these values, you'll see it pre-populate. So I'm going to take away Mars for a second. So let's say Mars is 1.532 AUs away from the sun. So I'm going to put 1.532 here, and then it is 1.88 Earth years away from the sun, or 0.88, I'm sorry, that's the period of revolution. It takes 1.88 years to go around the sun. And so we see that this populated the point for Mars. So you're going to finish these last few points for the red and orange, and then if you click on the other tab, the maximum and minimum distances from the sun, which are the yellow and green columns in this same chart. Okay. Then once you're done with that, you're going to fill out this see, think, wonder based on what you see. So you're going to write 2 connections that you see between the phase of water on an object. Like, is it solid, gas, vapor, or liquid? How does that relate to an object's distance from the sun? So make 2 observations and record them here. And then connect those observations to what you already know, or what you think the reason might be, and how it relates to what you already know about the sun, earth, their forces and energy. And then write a question that this leaves you with. All right, good luck.